Right, in this video, we're going to look at rational expressions. We'll define them, look at the domain, and then do multiplying, dividing, adding, subtracting. And finally, we'll look at some complex rational expressions. So to begin with, the definition of a rational expression is that it's a quotient or a fraction that involves polynomials. So here's three examples of rational expressions. Notice that there's a variable in both the numerator and the denominator. I don't know if I don't think you have to have one in both, but these are examples of ones that do. Okay, first and foremost with rational expressions, you need to understand the concept of a domain. As soon as you have a fraction, you have a possibility of having numbers that aren't allowed in the real number system. For example, try on your calculator, go 5 divided by 0 and see what that gives you. You notice your calculator will give you an undefined or it'll give you an error. In other words, you can't do that. So whenever we're dealing with rational expressions, we need to worry about numbers for which our expression is not defined. So for example, in this first one here, I can plug in any number I want, and that's what we're looking at for domain, is what are all the x's. So what are all the variables you can put in that are allowed? I can put anything I want in for x up the top there. But on the bottom here, if I put in a 1, that's fine. If I could put a 2, that's fine. But as soon as I put a 0 in the denominator, when you try and divide by 0, bzz, can't happen. So the domain of this expression here, I would say it can be anything except it can't be 0. This next case, again, I have an x on the bottom, but there's another number there, and that changes what number I can put in there. This time, if I put a 0 in, 0 plus 3 is 3. 3 is allowed on the bottom. But if I were to put in a negative 3 plus 3 is 0, can't happen. So this minus 3 is a number that's not allowed. So you'd say, in this case, you can put in any x as long as it can't be a negative 3. Here's a couple of examples, and I'll show you ways of writing them with set notation and interval notation. So this first question, there's no x on the bottom. If there's no x on the bottom, then in terms of what your domain is going to be, you'll say you can use all the x's as long as x is an element of the real numbers, and that's it. So anything will go. In interval notation, the way you would write that is this. So you'd say negative infinity is your smallest number, positive infinity is your largest number. Basically anything. Okay, this next question, it's got a quadratic in the bottom. And that means probably that there's going to be two numbers for which this thing isn't defined. In order to find out what those numbers are, though, I need to factor this bottom thing. So the top, I don't think I can factor that. It's always good to factor it if you can, but I don't think you can factor that one. But the bottom you can. And so I have an x and an x, I think a plus 7 and a minus 4. And then I have this up top, but in this case, since I can't factor, it won't make a difference. So here I'm asking what number can I not put in there? And if you're saying negative 7, you're right. In this one, it'd be a positive 4. So you'd say for set notation, you can put in any number you want as long as x is not equal to a negative 7 and x is not equal to a positive 4. Now in interval notation, this one's a little bit tougher because you have to set out intervals. If I were to write a number line for this, so it can't be negative 7, that's out, and a positive 4, it can't be. So I'd have to indicate an interval up to negative 7, then from negative 7 to positive 4, and finally from 4 up. So I would write that as, I could say from negative infinity all the way up to negative 7, not including negative 7. That's what the curly brackets are. And then from negative 7 to positive 4, those are numbers okay. And then from positive 4 up to infinity, those are okay as well. And to say you can do all of those intervals, you put a union sign in between them. Okay, so that would be the domain of that. Okay, try this. question on your own. Careful, I made a little trick on this one. Press pause, then press play. Okay, hopefully you took a look at it and realized that you needed to factor the denominator. So x squared minus 9 is a difference of squares, so the bottom will be x minus 3, x plus 3. And then also hopefully you factored the top. So this would be an x, things that multiply to 3, so I think x plus 3 and then x minus 1. Notice in this rational expression that I have common factor on the bottom and the top, so I can cancel both of those. So the only number that would be that would not work in the domain would be a positive 3. So you'd say in your set notation, you'd say plug in any x you want as long as x is not equal to a positive 3. Okay, and then for interval notation, so it can't be positive 3. So it can't be positive 3. That's right there. So it can be anything up to that and anything beyond that. So in interval notation, I would say you can go from negative infinity all the way up to 3, and you can go from 3 all the way up to positive infinity. That's a union of those two. Okay, now let's get into sort of like what we did in the last question, but I want to simplify rational expressions. And to simplify things, or when you're multiplying or dividing, or indeed when you're adding or subtracting, if you see a polynomial expression like this one, you always want to factor it. And then if you can remove a factor of 1, great, that's called simplifying. Okay, so let's try this first one. So to factor that, I think that's y plus 7, y minus 3, and the bottom is y minus 3 and y minus 3, I think. Notice that factoring has a big role to play here, so you want to be very good at factoring. So here's a common factor of 1 that I can eliminate, so my answer would be y plus 7 over y minus 3. Try that one on your own. Factor, see how you do, then press play. Okay, for this one, I think I can factor 12 out of the bottom, leaving me with x squared minus 1. On the top, I think I can factor 3 out, leaving me with 3x squared plus 2x minus 1, I think. Let's do some more factoring on the top there. That's a quadratic, so I should be able to do this with it. And on the bottom, that's the difference of squares. So x minus 1, x plus 1. So on the top there, both have to be 1s. So I'm just factoring. I need to get a positive 2x. So I'm thinking I put a plus there and a minus there. Let's check. 3x squared plus 3x minus an x. Yeah, that's 2x and a minus 1. Yeah, so it's correct. Now look for a factor of 1 that you can take out. So x plus 1, those both go. Now 3 and 12 I can simplify. If that hurts just doing it right as is, write it like this. 3x minus 1 over 12 is the same thing as 3 times 4 times x minus 1. So the 3's are a common factor of 1, they go. The 3x minus 1 and the x minus 1, they look similar, but there's no 3 here, so you can't simplify that any further. So you would end saying 3x minus 1 over x minus 1. Okay, when you're dividing expressions, you do the same thing as what we were doing there, factor, and then take out factors of 1. It's just you have to remember that when you're dividing expressions, you invert and multiply. So let's factor them all at the same time as we invert and multiply. So out of the first one, I can take a common y. Out of the next one, that's a difference of squares, y minus 3, y plus 3. I'm changing that to times, so I'm factoring this one and I'm putting it on the top. We've already done that a few times, y plus 7, y minus 3. Now let's factor this one, y plus 7, y minus 2. Now I'm looking for factors of 1 that I can remove. Right there's 1, right there's 1. Oh, right there's 1. And I think that that's all. So on the top, I'm left with a y. On the bottom, I'm left with y minus 2. Try it. So the first one I factor out of 3, factor out of 2, invert and multiply, so this would be a times, and I'll have my x minus 4 squared on the top. Notice I rewrote it with 2 of them, and I'll do the same thing with the bottom. Okay, now I'm looking for factors of 1 that I can take out. Here's an x plus 4, gone. Here's an x minus 4, gone. I think that would be all. So I'd be left with 3 times x minus 4 over 2 times x plus 4. Now you could leave it like that, or if you wanted to multiply it out, 3x minus 12 and 2x plus 8, you could do that too. This is probably a more simplified answer, but either of those I would give to you on a test. Okay, now let's turn our attention to adding and subtracting. Adding and subtracting rational expressions are just like adding and subtracting any other fraction. You need to find a common denominator. In this first question, they already have a common denominator. So I can write the common denominator, and then on the top, I just write what I have happening. Now notice that this one right there, I put brackets around things that I was subtracting. And that's an important thing to do. That minus sign right there, I call a dirty, rotten, filthy, stinking negative. And you have to be careful with it because you have to apply it to both terms in the expression. So to simplify this, I would write 4x plus 5 minus x plus 2 over x plus 3. Collecting like terms, I'd have 3x plus 7 over x plus 3. Notice if you mess up on any one of those negative signs in there, bad things happen. So you have to be careful. Here's another one where there's a little bit more to factoring that and finding a common denominator. First off, let's factor. Let me give myself more room. So I'll leave the 9x plus 2 on the top. On the bottom, I'm just guessing and checking. So 3x and an x. And then 8, 4, no, why don't we go 2 here and a 4 there. Let's make this negative and this plus. 3x squared minus 6x plus 4x, yeah, that'll give you minus 2 and minus 8. Yeah, that's right. Minus 7 over 3x and x. I've got to get a 1 out of the deal, so 2 and 2. I don't think that would be good. Let's do a 1 and a 4. Let's make this one minus and this one's plus. 3x squared minus 3x plus 4x. Yeah, that's right. Minus 4. Good. Okay, so I've factored each of them. So now I have to find a lowest common denominator. It's got to include each factor the most number of times that it occurs. And I always do this. I just pick one of the denominators. So it has to have a 3x plus 4 and an x minus 2 in it. And then I look at this one. I already have that one, but I don't have this one. So that needs to be included in the common denominator. Okay, so let's rewrite this. I'll have 9x plus 2 over 3x plus 4, x minus 2, and now I have to include that, x minus 1. But if I include it on the bottom, I'm also going to need to include it on the top. When I include it on the top, I would put this in brackets because I'm multiplying all of that by the x minus 1. Minus 7 over 3x plus 4, x minus 1. It has already, but it doesn't have this one. So I need to put that on the bottom and on the top. Now that I have a common denominator of 3x plus 4, x minus 2, x minus 1, now I can deal with the stuff up top. Let me just rewrite it first, and then I'll multiply it out and look for common factors. Minus 7 times x minus 2. You recognize what that is right there? Hopefully you said a dirty, rotten, filthy, stinking negative. Okay, so foiling that first one, I'll get 9x squared minus 9x plus 2x minus 2. On the next one, I'm going to get minus 7x and a plus 14 all over that lowest common denominator. Collecting like terms on the top, there's only one x squared term. Minus 9 plus 2 is a minus 7, minus another 7. So I'm doing these ones. That's minus 7, minus another 7 is minus 14x. And then minus 2 and a plus 14 is a plus 12. All over 3x plus 4, x minus 2, x minus 1. The only last thing I would do, just to check this, is to see if I could factor that. I don't think there's a way of factoring it to get, so 9 times 12 is 108. So things that multiply to 108 and add to 14, I don't think there are any. So I would leave this as my answer. Okay, try that one. Your turn. Press pause, then press play when you're done. Okay, factor first. Y minus 5, y minus 2, minus 2y over y minus 5, y minus 3. So my lowest common denominator is going to be y minus 5, y minus 2. Have that one already. I don't have a y minus 3. So that'll be my lowest common denominator. So let's write the first one with that. Y minus 5, y minus 2, and 3y. But then I'm including now, it needs a y minus 3 on the bottom and the top. Minus, this is what I have already, y minus 5, y minus 3. But I now need to include this one, y minus 2 on top and bottom. Okay, now I'm going to try and do 2 steps at once here. Hopefully I don't mess myself up. So I'll leave the common denominator. Now it's common, so I can just write one of them. And then on the top, I'm going to FOIL that. So it'll be 3y squared minus 9y. And this one, I have to remember it's minus 2y times both of those. So it's minus 2y squared plus 4y. Let me look at that. 3y squared minus 9y, yeah. Minus 2y squared plus 4y. Yeah, I'm happy with that. So now let's collect like terms on the top, leaving the common denominator on the bottom. So it'll be 3y squared minus 2y squared would be 1y squared. And minus 9y plus 4y would be a minus 5y. Now here's a good example of where you need to keep going. So that top one, you could now actually factor it. You can factor out a y, leaving you with a y minus 5. And then on the bottom, you have your common denominator. And notice that there is a common factor of 1 that you can take out. So your final answer will be y over y minus 2, y minus 3. That's a tricky one. Good. All right, the last concept we're looking at is complex rational expressions. So you have a fraction over a fraction over a fraction. And what you want to do is simplify this. And sometimes students in other parts like trig, they try and do leave a complex rational expression as their answer. And you always need to simplify it so it's just one thing over one thing, not a fraction over a fraction. I just want, I'm going to wind up with a fraction, but I want something over something. I don't want fraction over another fraction as an answer. I want to simplify that. The easiest way to simplify these is to find a lowest common denominator and then multiply both top and bottom by that. So here are my denominators. I've got an a b, an a cubed, and a b cubed. So my lowest common denominator for this will be a cubed and b cubed. And I know that because it's every factor the most number of times it occurs. So here I just have one a, here I've got 3 a's. So my lowest common denominator, I need 3 a's. 1b, 3 b's, lowest common denominator needs to include 3. Okay, so now let me rewrite this. 1 over a plus 1 over b over 1 over a cubed plus 1 over b cubed. So my lowest common denominator is this. So I'm going to multiply the top by a cubed b cubed. And if you want to think of that as over 1, that's okay. And then I multiply that on the top, and I need to multiply that on the bottom fraction as well on the denominator. Now I take and I'm multiplying this. I'll use a different color. I'm multiplying this by that, and then I'm multiplying it by that. And then I'll multiply this by that one, and this by that one. So in the first one, a cubed b cubed times 1 over a, one of those a's will cancel. So the only thing you're going to be left with is a squared b cubed. That's the only thing that you're left when you multiply this by that. The next one, so plus, with the next one, you'd cancel one of the b's. So you'd have an a cubed b squared over, let's check the bottom. So in this one, the a cubes will cancel, so you'd be left with just a b cubed plus, and then on the next one, the b cubed will cancel, so you're just left with an a cubed. Okay, you could probably factor something out of that top stuff. You could factor an a squared out, but you won't be able to cancel anything, I don't think. Let's try it. So I'm going to factor a squared out and a b squared. And if I do that, that'll leave me with a b plus a, and on the bottom, b cubed plus a cubed. You can't cancel anything else. So I would just leave it right there like that. Why don't you try one last one? Press pause, do it, then press play. Okay, so finding the lowest common denominator. Lowest common denominator, you have y's and x's, and you just have one of each. So your lowest common denominator is xy. So I'm going to take and multiply this by an xy over 1, and multiply this side by an xy over 1. Okay, I'm timesing. I guess I shouldn't have that equal sign in there. So when I multiply this by this, the y cancel, but I've got two x's there, so I've got x squared. And then this one times this one, the x cancels, but the y's don't, so I'd have minus y squared. Okay, on the bottom, I'd have the y's would cancel, so it would just be an x. And then the x would cancel, so it would just be a y. Is that right? Yeah. Now on the top, that's a difference of squares, so I could factor that. X minus y, x plus y over x plus y. And there you see the common factor of 1 that you can remove. So your answer would simply be x minus y. So in this video, we have looked at defining what a rational expression is. We've simplified them and simplified them when we're dividing or multiplying rational expressions. We've also looked at adding and subtracting rational expressions. Factor, factor, find the lowest common denominator, put them together. And lastly, we looked at simplifying complex rational expressions. So go ahead and do the video quiz, and then try the homework, and then try the quiz after that. If you have questions, as always, give me a holler.